Hello, everybody. My name is Ib6 I'm a senior technical trainer at the Indian Cybersecurity Solutions, and this is my informations, my contact numbers, LinkedIn, and Twitter. If you want to contact me, today I'm going to discuss about IPv4 versus IPv6. So first, I'm going to discuss about IP version 4, and then we'll move to IP version 6 features. What is an IP address all about? It is an unique identifier to identify a host or a PC in a network. So there are hundreds of PCs. To identify each PC, you need a unique address or identifier. It is known as IP address. It is network layer address and it is a logical address. So we can change the IP address. Now IP address has two versions, IP version 4 and IP version 6. In case of IPv4, what are the features of IPv4? It is a binary address, means it is denoted as 0 and 1. Its length is 32-bit long. It has 4 octets and 8 bits per octet. So there are different bits. So each octet has 8 bits. So for example, say these are like bits 1, 2, 3, 4, 5, 6, 7, 8, and then another octet. So this is the first octet. Okay. So this is the octet 1, and then there is octet 2, 3, and 4. So there are 4 octets and 4 into 8, 8 bit per octet. There is a 32-bit structure. Like it is written here 172.16.254.1. This is what? This is an IP address. And you can see we can convert each decimal in its corresponding binary equivalent. We write it in decimal format, but actually it is produced in binary. So there are 8 bits as I've already shown you, and total is 32 bits. Now in case of IP version 4, there are different classes like class A, class B, class C, class D, and class E. Now we only use class A, B, and C because D is reserved for multicast and E is reserved for scientific research. Now these are the patterns of the first octet of class A. First bit is 0, it is a reserved bit, and the range of class A is 1 to 127. Host to be assigned here is 1.0.0.1 to 126, 255, 255, 254. So these addresses you can assign. In case of class B, it is first bit is on and the second bit is off. These two bits are reserved bits. This is a bit pattern of class B, and the address range is 128 to 191, means 128.001 to 191, 255, 255, 255, 254. In case of class C, that's 110 means first two bits should be on and the third bit should be off. These are the three reserved bits, and the range is 192 to 223, means 192.001 to 223.255.255.254. And also class D range is 224 to 239, 111 and 0, and 11110. This is the reserved bits for class C. The range is 240 to 255, but these are not used in case of LAN or WAN. That I've already told you that class D reserved for multicast address range and class C for higher scientific research or experimental purpose. So we have to remember these three ranges of class A and B and C very carefully. Now in class IPv4, there are two types of addresses. One is private IP and one is public IP. Now public IP is used in case of WAN environment. In case of ISP service providers, they use a public IP. Now, the private IP is used in LAN or local area network. There is a range of private IP address that we use in LAN. What are the ranges? Class A, B, and C. A has a range of 10.0.0.0 to 10.255.255.255. B is 172.16.0.0 to 172.31.255.255. And class C is 192.168.0.0 to 192.168.255.255. So this range is used in case of LAN communication. Beyond this, you cannot use. Beyond this, all the IP addresses are public IP. Okay. Now there is a thing called subnet mask. Now, what is the subnet mask? So in the next slide, we have discussed about the network ID and host ID, and this is related to the subnet mask concept. In case of class A, the first octet is network ID. In case of class B, the first two octets are network ID, and class C, first three octets are network ID. And in case of class A, host ID are the last three octets, class B, two network ID and two host ID, and class C, three network IDs and one host ID. Now, what is about this network ID and host ID all about? Network ID means how many networks we get from each class, how many subnetworks or networks you can derive from a class. And host means IP address, how many hosts, how many pieces, how many IP address you can get from any classes IP address. Now, in case of class A, what happens? In case of class A, the first octet is the network part. And in a network part, remember, all bits are on. Means this. If all bits are on, the value would be 255. In case of class B, we know that first two network parts. So there will be 255.255. And in case of class C, network, network, network. So first octet is a network ID and the last octet is host ID. In case of host ID, all would be 0. Here also host will be 0. 0.0.0. This is the host. This is the host. And this has only one octet as the host part. So the subnet mask of class C would be 255.255.255.0. So in network part, all the bits are on, and in host part, all the bits are off. So you can easily see that in case of class A, we get the maximum number of hosts, and in case of class B, it is almost equal 16 bits. It's almost equal 16 bits for network and 16 bits of host. In case of class A, 8 bits of network and 24 bits for host. And in case of class C, we get maximum number of networks, that is 24 bits, but only 8 bits for host, means IP address. So actually, in a LAN environment, we use the class C IP address, because in class C, we get only 8 bits for host. And class A and B is generally used for ISP and ISP public IPs. Now, I was talking about the default subnet mask. So I've already told you that in case of class A, the first octet is network, and in case of that network ID, all bits are on. So that is why the value has come as 255. And in case of class B, there are two network IDs parts, so 255, 255. And in case of class C, there are three network IDs, so 255, 255.255. So actually, subnet mask is a 32-bit value, which actually identifies the classes of an IP address and also the network ID and host ID. Okay. So this is all about the IPv4 address. Now, I'm going to tell you about the IPv6 address, and then later we'll see how to configure these IP addresses on routers and PCs using Cisco Packet Tracer. Now, in case of IPv6 address, what is the differences between IPv4 and IPv6? There is a major difference. Now, why IPv6 came? Because IPv4 was almost exhausted. So we look for another IP IP address space or another IP version, should I say, and then the IPv6 emerged. IPv6 is hexadecimal address. It is not a binary address. It's a hexadecimal address and it is derived from the MAC address of a PC. Now, it has no categories of private and public addresses like in IPv4. Means, in case of IPv6, we do not clearly say that these addresses or this range of IP addresses is private address and these range of addresses are public address. No, we do not do that. Definitely, there are some addresses which are equivalent to the private and public address of IPv4, but we do not say it clearly in IPv6. So, for that, NAT is also not used, means it's not required because NAT or network address translation is used to transfer between private and public address or public to private in case of IPv4. In case of IPv6, it is not required. Now let's come to the IPv6 address space. In case of IPv4, I talked about the 32-bit address space. Here is a 128-bit address space. Now see, in case of IPv6 address, say this address starts with 2001, 0db8, anything you can start with any hex digit. Now 64, 64, these are the two parts. So this first 64 bits, this is the network part, and the second 64 bit, it is the interface ID or the host part. Now, in case of the 64 bits, first 64 bits, we can also subdivide those bits into register prefix. See, slash 23 means what? Means the 23 first 23 bits up to this is register prefix. First 32 bits are ISP prefix. 48 bits are site prefix, and up to 64 bits is a subnet prefix. Because in case of subnet, this is a subnet ID, you get the 16 bits for subnet. Now all the 48 bits up to this slash 48 up to this from register prefix to this site prefix, this is called the global prefix and that is assigned by the ISP. Now after that, I've already told you get the 16 bits for the subnet space and it is known as the subnet prefix. And the rest 64 bits are called interface ID or host ID, and here we get the IP address from the MAC address of any PC. So this is about the structure of the IPv6 address space. IPv6 address has 8 quartets. Now what is a quartet? I've already talked to you about the octet in case of IPv4. Octet means 8 bits and quartet means 16 bits. There are 8 quartets, 16 into 8, there is a 128-bit address space, 16-bit per quartet. Now there is an example of IPv6 address starting as 2001 colon 0db8 3c4d 0012. This is your subnet. This is your subnet, and then all are zeros, means the interface ID or host address is total 0. We haven't configured the host address yet, and the slash 64, it is the IPv6 prefix, means the 64-bit network ID and 64-bit host ID interface ID. Now we can shorten this address format by omitting leading zeros. Means what? Means this 0 or these zeros. These are the or these zeros. We can also shorten it like 2001. We can omit this leading 0, not these zeros, because this is in between zeros. We cannot omit that, but we can omit the leading zeros. We can omit it and write db8 in case of 0 db8. Principal is as it is, and see 001 to the subnet part, we can shorten it as 1212 only. And then you even do not need to write any zeros of the interface ID. You just give double colon. That will make it. So we have shortened the IPv6 address space and then the IPv6 prefix slash 64. So we have not even written the interface ID or the host ID. So this is how you can shorten the IPv6 address space by omitting the leading zeros only. Then let's discuss different IPv6 address types or addresses. Now there is a global unicast address. This is actually like your IPv4 public addresses. I've already told you that definitely there are some addresses in IPv6 which are like IPv4 public addresses. What are they? They are global unicast addresses, unicast packets sent through the public internet. So these are the routable address via router, and it is a routable address, and it uses the prefix 2000, and it is easily seen hex prefixes like 2 or 3. So it starts with 2 or 3 hex digit. There is a unique local address, unicast packets inside one organization. Now, this unique local address, it has become like private IP address in case of IPv4, and it is routable. Just like IPv4 private address, it is a routable private IPv4 address. It starts with FD00, FD. Now, link local address, the third one, is a packet sent in a local subnet. It means it is not routable. It is a non-routable address. And it is what we call in IPv4 the APIPA address, automatic private IP addressing. If you haven't given the static IP address and also your DHCP server is not available, then this link local address is assigned to the network adapter. And in case of IPv6, it is automatically assigned to the network adapter, but it is non-routable. So it is only used inside the local subnet, and it starts with FV8, FV80. Actually, FV80 prefix is it can start according to RF says it should start with FE8, FE9, or FEA or FEB, but the bit positions of 11 to 64 link local address should be 0. So in that case, in practice, link local addresses begin with FE80. So anyway, this actually begins with FE80, not as FE8. So we should remember that FE80 is actually the link local address like the APIPA address, but it is not used because it is not routable. Now, there was a site local address, but now it is not used. It is deprecated now. It is not used. Originally, it meant to be used like private IP for addresses like FEC0, FEC, FAD, FEE, FEF, that's like that. But now it is not used. Now only global unicast is used for public use, public routable address, unique local for the private address, and link local for APIPA address. And there are unspecified addresses and loopback addresses, also double colon 1, that is also used for software testing, like loopback address, just like 127.0.0.1, that we use for software testing or self-diagnostic tests for IPv4, that is there also in IPv6. Now, that is telling you that unique local is used as IPv4 private IP. You can compare this as IPv4 private IP, and it starts with FD00. Global Unicast address is used as IPv4 public IP. It is compared to IPv4 public IP, starts with 2000 digits, and link local is like IPv4 APIPA, starts with FE80. So these are the actually three addresses nowadays used in case of IP version 6. So this is about the address types. And now I'm going to show you in Cisco Packet Tracer how to configure the addresses. First, I'll show you how to configure IPv4 addresses in router and in PCs, and then the IPv6 addresses. Now, this is the Cisco Packet Tracer console. You open this and you take a router there, and you take any device, any laptop or any desktop. You take it and connect it to this fastness 0 by 0 or 1 by 0. I'm connecting it with F0 by 0 to the laptop's fastness port. You go to the router, config mode, and go to interface fastness 0 by 0. Open this port node chart. If the IP before address first is very easy, IP address, say it's 10.0.0.1. This is class A IP, private IP, right? 255.0.0.0 is a default Subnet mask of class A that we have already seen. So this is the IP address configured on the first port, first 0 by 0 port on the router. And you can go to the PC also. So you go to the PC, stop IP configuration, and in case of static IP address, you give the 10.0.0.2 default mask and change the default gateway to 10.0.0.1. That is assigned to the router's F0 by 0 port. And now you can definitely ping the router, ping, and then 10.0.0.1. Now it's pinging. So this is how the IPv4 address is assigned in case of router, port, and on PC. And also from router you can ping the PC, that is ping 10002 from the privilege mode of the router, and it's pinging. It's 100% successful. So this, we already know how to configure the IPv4 addresses on PCs as well as on routers. But if I tell you to configure IPv6 addresses, then how to do it? So in that case, what you can do, you take another router, because in case of this beta router, the IPv6 is not supported. So I'm just omitting this router and I'm taking a different series router, say 1841 or 2620XM, anything you can take, and connect it again to the Ethernet port. And now I'm showing you how to give the IPv6 address on the router and then on the PC as well. You give the command IPv6 unicast hyphen routing. Without issuing this command, you cannot configure IPv6 address. Your router iOS will not take the IPv6 address. Okay. Now you go to the Ethernet port. Noted command to bring the port up, and then you give the command IPv6 address. Say Ib8 40 12 colon /64. Now I obviously do not want to give the total IP address which is derived from the MAC address of the router port. I am going to use a method called the automatic IP assignment EUI64 method, extensible user interface, which will automatically assign IP addresses to my router. Say, now you just see the IP address. This is known as the stateless auto configuration, the EUI64. You gave show IPv6 interface. If you see, this is the IP address, link local address. Now, this is the address that we have assigned to the routers and port. It starts with 2001, the global linkers address, DPI 34012 is the subnet ID, and this is actually derived from the MAC address from the router port. And actually, it has inserted a field known as FFFE inside this address. Now, this is a very interesting thing. This is known as the Ib6 padding. So we have to insert a double F, double F, and FE field. So say for example, I have a MAC address. Anything, say 3E, 5D, 1A, BD, and 0EC9. So this is our MAC address. Now the MAC address is actually 12 digit or 48 bit. So we have 16 bits missing. We have one quartet missing. So what EUI64, the stateless auto configuration, will do? EUI stands for extensible user interface. This EUI64 method will do, it will split these middle part of the MAC address into two halves. Like it will be 1A, then F colon, before BD it will be FE. So now this is 1, 2, 3, 4. So we have already added this FFFE 16 bits. This is known as a padding in case of UI64. And if you use this method UI64 in router, then you do not need to worry about this because UI64 is done automatically. And also, if you want to assign the IPC address to a PC using the DHCP version 6, so DHCP version 6, DHCP server also does this. But if you want to statically assign the IP address, manually assign IP address to each PC, then you have to do it manually. So this was about the IPv6 address. Now, if you want to assign addresses to PC, what you can do in packet tracer, you just copy this address, you just copy it, go to the laptop, go to IP configuration. Now it is IP4. Below it is IPv6 configuration. Now just paste in Control V the router IP address. Give the prefix as 64 IPv6 prefix, and see the link local address is automatically generated. Now you have to change the last bit. You can only change the last bit. The last bit is 05601. Now give 5602. So this becomes your basis IP address, IPv6 address. Now you can definitely ping the router's IP address from this PC. So what you can do, you close this, you go to command prompt, ping, and then you paste the routers. This is the router's IPv6 address assigned to the router's first design 0 by 04. Ping from the PC. Definitely the PC can ping, say it is pinging the router's IPv6 address because it has the IPv6 address also. And now you copy the PC's IPv6 address. You copy this PC's IPv6 address. You just copy it and you go to the router right here, ping, and you just paste it. Paste the PC's address. The PC's address. Yes, the router is also pinging the PC's IPv6 address. So you can assign any addresses. You can also assign unique local addresses, also FD00, also on the router port. I have assigned the global unicast address. Okay, so this way the IPv6 address can be assigned to the router using the UI64 format and also on the PC. So I've shown you how to assign the IPv4 as well as IPv6 address using Cisco Packet Tracer, and also I have told you what are the differences of IPv4 and IPv6. The address space is different, 32-bit, that is 128-bit. IPv4 is binary, that's it. And IPv6 is hexadecimal. In case of IPv4, there is private public address, but in case of IPv6, there is no clear distinction between private public. Of course, there are addresses, but there is no clear part distinction. NAT is not there in case of IPv6. So the interface ID is huge 64-bit. There are no classes in case of IPv6. So these are the differences I've told you about the IPv4 and IPv6. So I think this is clear to you, and I hope it's been informative for you and you enjoyed it. So that's it for today about the IPv4 and IPv6. And on any other day, we'll meet with some any other topic. So till now, it's bye.